What if I told you that there were once stars so massive, so powerful, that they defied everything we thought we knew about the cosmos? These were not the stars we see today. They were giants, burning with a fury unimaginable, their hearts collapsing into black holes before our very eyes. They lived fast, they died hard, and their legacy shaped the very structure of the universe. In the early universe, amidst the chaos of creation, these titans burned brightly for a brief moment before vanishing, leaving only their shadows behind. The Quasi Stars, mysterious, powerful, and ultimately forgotten, are the key to understanding the birth of supermassive black holes and the galaxies that surround them. Join us as we journey back to the very dawn of time to uncover the secrets of these lost giants, stars that were born in fire, consumed by darkness, and left behind a cosmic legacy still felt across the universe. The Forgotten Giants. Imagine a time when the universe was still young, just a billion years after the Big Bang. Galaxies were forming, stars were igniting, and cosmic structures were beginning to take shape. But in the depths of this chaotic, turbulent era, something truly extraordinary was happening. These weren't ordinary stars. They weren't even like the supermassive stars we see today. They were bigger, hotter, and more short-lived than anything that exists now. These were Quasi Stars. With masses hundreds of thousands of times that of our Sun, these colossal objects pushed the very boundaries of what a star could be. They burned with a fury that makes even the brightest supernovae look like mere flickers. To put this into perspective, our Sun, as mighty as it seems, is a dwarf compared to these cosmic giants. A quasi-star's core could reach temperatures in the hundreds of millions of degrees, its outer layers stretching across hundreds of thousands of kilometers. If placed in our solar system, a quasi-star could easily extend beyond the orbit of Jupiter, swallowing the inner planets whole. But what made them truly unique wasn't just their size or brightness. It was their hearts. Deep inside these giants, at their very cores, something unimaginable was happening. As they burned, their immense gravity crushed their cores to such extreme densities that a black hole began to form. Yes, a black hole, right at the heart of a star, a cosmic contradiction that shouldn't exist, but somehow did. And as the black hole grew, it fed on the star around it, consuming matter faster than it could radiate energy away, trapping light itself. This was the paradox of the quasi-star, a star that burned itself alive, collapsing into darkness even as it blazed brighter than entire galaxies. As the black hole within grew, it triggered a catastrophic feedback loop. The star's immense gravity crushed its core further, while the black hole at its heart devoured it from within, swallowing billions of tons of gas each second. This violent process released immense amounts of radiation, briefly turning the quasi-star into one of the brightest objects in the universe, outshining entire galaxies. But this violent brilliance came at a cost. The very process that powered these giants also sealed their fate. As the black hole consumed the star, it reached a point where the outer layers could no longer resist the pull of gravity. The star collapsed entirely, disappearing into the abyss of its own making. And just like that, the quasi-star died. A brief, catastrophic life, but one that left an indelible mark on the cosmos. But how could such a thing exist? And what role did these monsters play in shaping the universe we know today? To answer that, we need to journey back to the beginning. Birth in chaos. Quasi stars were born in the extreme violence of the early universe, a time when the first galaxies were colliding and merging, and the vast clouds of hydrogen and helium left over from the Big Bang were collapsing into the first generations of stars. But for a quasi-star to form, something even more extreme had to happen. Imagine a massive cloud of primordial gas, thousands of times the mass of our Sun, collapsing under its own gravity. As it fell inward, it heated up, its core igniting in a burst of nuclear fusion that would become the heart of a quasi-star. This initial collapse likely took place in the densest regions of the early universe, where galaxies were still forming and colliding in a chaotic dance of gravity. Shock waves from nearby supernovae, the violent birth cries of early stars, may have also triggered these collapses, pushing massive clouds of gas into dense, compact regions where they could form these early titans. The explosive energy from these supernovae would send shock waves rippling through the surrounding gas clouds. These shock waves, in turn, compressed the gas even more, initiating the collapse of these clouds into dense knots of material. These dense regions were highly unstable, and the intense pressure from the shock waves accelerated the formation of massive stars. It was this combination of extreme gravity and external shock waves that set the stage for the birth of quasi-stars. But this wasn't just a regular star formation. This was a cosmic inferno. As the gas fell inward, temperatures soared to hundreds of millions of degrees. The core ignited, releasing an intense burst of energy that pushed outward, struggling to hold back the crushing force of gravity. Yet this balance was fragile. The core was so massive that as it burned, it created a black hole at its center, a region of space where gravity becomes so intense that not even light can escape. And this is where the story of a quasi-star truly begins. A star so massive, so extreme, that it creates the seeds of darkness at its very heart. In the densest regions of the early universe, galaxies were still colliding in a cosmic dance. The intense gravitational forces generated by these collisions caused shock waves that rippled through the surrounding gas clouds. These shock waves may have compressed the clouds of gas even further, making them denser and more prone to collapse. At the same time, supernovae from nearby stars, the explosive death throes of the universe's earliest stellar generations, created violent shock waves that reverberated through space, triggering the collapse of nearby gas clouds. These shock waves added an extra layer of energy to the collapsing gas, hastening the formation of massive, unstable stars. The combination of these forces, gravity, shock waves from supernovae, and the violent merging of galaxies, set the stage for the birth of quasi-stars. They were born not in quiet, calm regions of space, but in the heart of a cosmic storm, where every force was pushing them to become something far beyond the limits of what we understand as a normal star. As the gas collapsed inward, temperatures soared to unimaginable levels, igniting nuclear fusion in the core. But unlike the stars we see today, these first stars were not just simple fusion reactors. Their immense mass triggered a series of catastrophic events that led to the creation of black holes at their very centers. This was a cosmic furnace, a place where new forces, gravitational collapse, nuclear fusion, and even the formation of black holes were working together to form stars that were not just born in fire, but were born in chaos. But what happens when the first generations of quasi-stars form? What do their massive cores and dark hearts mean for the evolution of the universe? Let's explore the catastrophic birth of a quasi-star, where light is swallowed and gravity reigns supreme. The legacy of giants. The story of quasi-stars is one of extremes: the birth of the first giants, their explosive deaths, and the black holes they left behind, which would become the anchors of entire galaxies. But to truly appreciate their impact, we need to understand the incredible influence these cosmic titans had on the early universe. One of the most profound impacts of quasi-stars was their role in shaping the structure of the universe itself. These behemoths didn't just collapse into black holes. They actively influenced the formation of galaxies, superclusters, and the cosmic web that stretches across the known universe. Their gravitational pull, even in death, has helped shape the very framework of the cosmos. The rise of galaxies and supermassive black holes. The death of quasi-stars marked not just an end, but a new beginning. Their collapse into black holes set the stage for the birth of entire galaxies, laying the gravitational foundations of the universe as we know it. These black holes became gravitational wells, pulling in gas, dust, and dark matter. These dense regions became the seeds of galaxies, forming the gravitational centers around which the first galaxies coalesced. Over billions of years, these black holes consumed vast amounts of matter, growing into the supermassive black holes we find today at the centers of nearly all large galaxies. But this process was not just about gravity. As these early black holes consumed matter, they released enormous amounts of radiation, creating powerful jets and winds that blasted through the surrounding gas. This feedback process, known as quasar outflows, helped regulate the growth of galaxies by blowing away excess gas, preventing the formation of too many stars too quickly, and allowing galaxies to form more slowly over billions of years. This balancing act, the push and pull of gravity and radiation, is what allowed galaxies to evolve into the massive, complex structures we see today. Without this process, the universe might look very different, with galaxies either collapsing into black holes entirely or remaining small, chaotic clusters of stars. The cosmic web, a universe shaped by giants. As these supermassive black holes grew, their gravitational influence reached far beyond their immediate surroundings, pulling on the surrounding dark matter and creating the vast cosmic web that connects all galaxies. This structure became the backbone of the universe, guiding the formation and growth of galaxies across billions of years. As their black holes grew, they created immense gravitational wells that pulled on the surrounding dark matter, helping to form the filaments and nodes of the cosmic web. The vast network of galaxies and dark matter that spans the observable universe. This cosmic web is not just a random distribution of matter, but a carefully balanced structure, shaped by the gravitational pull of countless black holes over billions of years. The formation of this web was influenced by the very first supermassive black holes, the direct descendants of quasi-stars, building the elements of life. The influence of quasi-stars goes even deeper. These elements became the seeds of planets, atmospheres, and eventually, living organisms. Without these early explosions, the chemistry of life itself might never have emerged. When these titans exploded or collapsed, they likely released vast amounts of heavy elements, the building blocks of life itself. Elements like carbon, oxygen, nitrogen, and iron were forged in the hearts of these stars and scattered across the universe by their explosive deaths. These elements later became the raw material for new stars, planets, and eventually, life itself. In a very real sense, the atoms in our bodies, the carbon in our cells, the oxygen we breathe, were created in the hearts of quasi stars billions of years ago. The search for their shadows. Today, astronomers are still searching for the remnants of these ancient giants. While we may never directly observe a quasi-star, the black holes they left behind continue to shape the universe around us. Every time we peer into the heart of a distant galaxy, we are glimpsing the legacy of these long-dead titans. New telescopes, like the James Webb Space Telescope, are pushing the boundaries of our understanding, peering deeper into the early universe than ever before. These instruments may one day find direct evidence of the first quasi-stars, revealing new insights into how the universe formed and evolved. A legacy written in the stars. So, as we look up at the night sky, at the bright stars and swirling galaxies, we are really looking at the descendants of these long-dead titans, echoes of the first fire that lit the darkness. Every time we peer into the depths of space, we are looking at the cosmic legacy of the quasi-stars. Their influence is written into the very fabric of the universe, from the structure of galaxies to the elements that make up our world. And their story is still being written, one discovery at a time. Though quasi-stars themselves have long since vanished, their legacy lives on. The black holes they left behind are now some of the largest objects in the universe, swallowing stars, bending light, and shaping the very fabric of space and time. These black holes, born from the collapse of quasi-stars, are the ancestors of the supermassive black holes found at the centers of galaxies today. To truly understand the impact of quasi-stars, we must first examine the creation and significance of black holes. These objects, once thought to be anomalies, are now known to be fundamental forces in the universe, influencing everything from the structure of galaxies to the formation of stars and planets. And the quasi-stars were the ones to lay the groundwork for their creation. Without quasi-stars, the galaxies we see today might not exist. These ancient behemoths helped seed the supermassive black holes that now sit at the hearts of galaxies, driving their growth and influencing the formation of stars and planets. In a sense, every galaxy in the universe, including our own Milky Way, is a monument to these forgotten giants. As quasi-stars burned out, leaving behind their black hole cores, the gravitational influence of these black holes began to shape the space around them. They acted as cosmic engines, pulling in surrounding material and triggering the formation of stars, planets, and even entire galaxies. The birth of galaxies, as we know it, was driven by the gravitational pull of these supermassive black holes. They were not just passive remnants of the past, but active forces that helped form the very structures of the universe. As they fed on gas, dust, and nearby stars, they powered the growth of galaxies, creating the vast cosmic structures we see today. But the legacy of quasi-stars doesn't stop there. The process of galaxy formation and the creation of supermassive black holes are intertwined. As galaxies formed and merged, the black holes at their centers would eventually collide, merging into even larger black holes. This process, called galactic cannibalism, played a crucial role in the evolution of galaxies and the supermassive black holes that now reside at their cores. In fact, Some scientists believe that the supermassive black holes at the centers of galaxies are direct descendants of the black holes formed from quasi stars. These black holes, which can be billions of times more massive than our Sun, continue to grow by consuming surrounding material, feeding off the gas and stars around them. Over time, these supermassive black holes became the gravitational engines of entire galaxies, pulling matter toward them and shaping the evolution of the galaxies they reside in. Furthermore, quasi stars may have played a role in the creation of the very elements that make up our world. As these stars exploded, they likely released heavy elements into the universe, enriching the surrounding gas clouds and providing the building blocks for future star and planet formation. It is through this process that the elements that make up life on Earth, carbon, oxygen, nitrogen, and others, were formed. These elements were scattered throughout the universe, seeding the next generation of stars and planets. And in this way, quasi-stars didn't just create black holes, they also helped to create the building blocks of life itself. But what does this mean for us today? It is a legacy that transcends time and space, shaping everything from the formation of galaxies to the creation of life itself. The black holes they created are the key to understanding the forces that govern the universe, and their influence can still be felt in the way galaxies evolve and grow. Moreover, the quasi-stars' violent deaths provided a way for the universe to evolve. Their explosive end led to the creation of black holes that, in turn, helped form galaxies and even triggered the birth of new stars. This process of rebirth, where death fuels creation, is a fundamental part of how the universe works. In a sense, the story of quasi-stars is not one of destruction, but of creation. They were the architects of the cosmic landscape, shaping the universe in ways we are only beginning to understand. And as we continue to study these ancient behemoths, we may uncover even more secrets about how the universe came to be. The legacy of quasi-stars may be far from over. Each new discovery about these giants opens a window into the past, shedding light on the forces that shaped our universe, and the dark, mysterious giants that laid the foundation for the cosmos as we know it. So, as we look up at the stars tonight, let us remember the quasi-stars, the giants who lived, died, and gave birth to the universe we now call home. In the end, the story of quasi-stars is one of cosmic cycles: birth, death, and rebirth. These ancient titans blazed brightly in the early universe, creating the first black holes and seeding the galaxies that now fill the night sky. They were the first architects of the cosmic web, shaping the very structure of the universe and laying the foundation for the galaxies, stars, and planets that came after. Though they vanished billions of years ago, their impact is still felt today, echoing across the cosmos in the form of supermassive black holes and the elements that make up our world. In a very real sense, we are all the children of quasi-stars, the descendants of their explosive deaths, and the cosmic matter they left behind. And as we continue to explore the universe, let us remember that even the most extreme and short-lived phenomena can leave a lasting legacy, written in the very atoms of our being and in the stars above. Thank you for joining us on this journey into the past as we uncovered the secrets of quasi-stars. If you enjoyed this deep dive into the mysteries of the cosmos, don't forget to like, subscribe, and hit the notification bell so you never miss a journey into the unknown. This is Galaxive, where the universe is our guide, and the stars are our storytellers. Until next time, keep looking up. Their legacy lives on, not only in the black holes they left behind, but in the very fabric of the universe itself. And their story is still being written, one discovery at a time.